A very quick one, guys. We're going to focus on our lesson 2, right? And then we are going to look together into what is called your heating curve. So there is heating curve and there is cooling curve. You see the exam questions, let me say 80% of the exam questions are inside your heating and your cooling curve. And then you must pay solid attention. Let's say, for example, okay, when we say heating curve, the simple question is, what is heating curve? First, note this, that heating curve is the graphical representation of the change in states as a substance is heated. So that graphical representation of change in states when you heat a substance, what is it called? It is called your heating curve. And of course, heating curve is different from cooling curve. Let's say, for example, we have something of this nature. You can see your y-axis and your x-axis. On your y-axis, let's say that's where we have temperature in degrees Celsius. But on the x-axis, we have time in seconds. So we are taking record of time as against your temperature in degrees Celsius. Now follow me from here very fast. You see, how do we get our heating curve? You know, when you are heating something, the temperature will start from minimal, like 0, and start to go up, right? And you can see the way this graph is positioning itself. It moved up, then like at equilibrium, moved up, like at equilibrium, moved up again. All of this represents something very lovely that you must know. I'd like you to follow me as you look at it much more broader, right? Here is what you must understand very fast. Now, let's say this is our 0, which is the origin. And then here is your A. Here is your your B. Here is your point C. Here is your point D. And then here is your point E. You can see all the various points one after the other, right? Let's say, okay, we now decide to say, you see our AB, your point AB. Can we trace it upwards? And then you see, it's more like slope, right? The one that is slope again is your CD. Let's trace it upwards, and then let's see something lovely. You see, from 0 to A, that is your solid. Because you will start with solid in heating, and then you will transition from solid and move all the way to where your liquid BC. And then your DE is your gas. So we have your solid, your liquid, and your gas. You can see 0 to A is solid. Your B to C is liquid. Your D to E is your gas. Now, but this is where it gets very much interesting. I'd like you to know this very quickly, Winnie. That you see your AB, right? That is where melting occurs. Oh, stop whining me. Your AB is where melting occurs. And you can see that the temperature there is constant where melting is occurring. Okay, follow me, Matt, they show you. Now, what about, okay, if that, what is occurring actually melting? In that melting point, what's happening there? That's where your solid transitions to liquid in that melting. And of course, your CD, what will it be? Of course, that's your boiling, right? If that's boiling, what will occur there? It is where your liquid will transition into your gas. That's where boiling occurs. Oh, Sir Peter, talk to me. Follow me. Let me show you something lovely. You see where your melting is occurring. Let's trace it down to the temperature axis. That point or that temperature is called your melting point. You see where your boiling is occurring, take it to the temperature axis. You see that point, right? What do we call it? It is called your boiling point. So we have melting point and we have your boiling point. Anyhow they bring these questions, ensure you destroy them. You can see that the temperature for your boiling is constant, it's at equilibrium. Temperature for your melting is at equilibrium. So melting and boiling point, they are at equilibrium there, right? So you can see your solid, equilibrium, liquid, equilibrium, then to your gas. Please don't play, because we are going to be looking at all the exam questions very, very fast. I wouldn't want to dive deep, your pause, so that by the time we get to the exam questions, I will see what you can do. But please understand this, what is called your cooling curve. What is it called? Cooling curve. The quick question is, what is your cooling curve? First, a cooling curve represents the change in states as a substance is cooled. That change in state that occur when a substance is cooled, what is it called? It's called your cooling curve. And of course, let's say we have our graphical representation like this, and of course, this is your what? Your y-axis, right? Which is temperature. On your x-axis, we have your time in what? In seconds. It can be seconds, it can be minutes, anyone they give us. In your cooling curve, am I moving from, is the temperature already high? I want to reduce it. But temperature is low, I want to increase it. In your heating curve, heating, you start it from 0 and start to increase. In cooling curve, temperature is already high. You want to start what? Reducing it. So we're going to have something like this. Share this here now. We are coming all the way from up, then what? Downwards. And you see we step down, equilibrium, step down, equilibrium, step down. Share you are seeing it now. And of course, let's look at it much more what? Bigger. And let's say, okay, we are picking out this point. You already know that something lovely is going to happen there. And then we're also picking out this point. Let's call here our A. Let's call here our B. Let's call here our C. Let's call here our D. Let's call here our E. And let's call here our what? F. You know, since this is your what? Your cooling curve. What is going to happen? You are going to start cooling gas. So the AB there is your gas. You move from gas to what? Liquid, which is your CD, and then from liquid to your what? Your solid. Very, very simple. Share this here now. Since I'm coming from my gas to liquid, from liquid all the way to what? Solid. Something should start to enter into me. From liquid to, from gas to liquid, what should happen there? That is your what? Your condensation. That is where condensing will occur. So your BC, condensation is occurring there. For gas to move to liquid, of course, now there must be condensation. So how do I know that is condensation? You see, when your sunlight hits water bodies in real life, what happens? Vapor move, and then they gather as cloud, right? And when the atmosphere can no longer hold the cloud, what happens? They will precipitate upon the earth as rain, and that process is called your condensation. So for gas to move to liquid, that's what condensation. But from liquid to gas, well, before we even move from liquid to solid, first, what is occurring in condensation? What is occurring in condensation is that your gas is converted into liquid. And of course, you're now in the liquid state, which is your CD. From CD, what happened? Of course, DE is what we're going to have. That DE, freezing is going to occur there. Because I need to move from my liquid to solid. Picture it in your head. To move from liquid to solid is just like you carry your normal water, right? Liquid, put it inside your fridge. Is that not freezing? And then solid is bettered? Yes. So what is occurring in that freezing there? What is occurring in that what? Your liquid is transitioning into your solid. Can I show you something more lovely so that you can see something sweet here for yourself? Now follow me, let me show you something. You see, that condensing point, can I trace it to temperature? Yes. And what do we call that? That is called your what? Your condensing point. That point that we have on that temperature axis, that's called condensing point. And that's where condensation occurs. What about for your freezing? Trace your freezing. If you trace your freezing, of course, what points are you going to have there? You're going to have your freezing points. Are you feeling me? If you get this very well and you are sure that you understand it, let me not go far again, bro. Hey, we're going to look at your past questions in the next class. And guess what? That's our lesson 3. And then we're going to start with your Jamb past questions first. I'll see you in the Jamb past questions there. After the Jamb past questions, we're going to look at the Waec past questions. Ensure you don't fail anyone. If you fail anyone, I'll be very, very angry with you. I'll see you in that class. Enjoy. One love. Bye-bye.